the operations on matrices or the algebra of matrices, and in the operations or the algebra we have discussed first addition of two matrices. We just recall it. So we said, first of all, what we said, it is not possible to add any two matrices. For adding two matrices, there is a certain condition, and the condition is the two matrices must be of the same order. Okay, and if the two matrices are of the same order, then their sum is again a matrix, and it can be obtained by adding the corresponding elements of the two matrices. Thereafter, we have discussed how to do the multiplication of a matrix and a scalar. What we said, a matrix and a scalar can be multiplied by multiplying each and every element of the matrix by that scalar. Okay, then we have discussed how to obtain the negative of a matrix. What we said, the negative of a matrix A is minus A, and it can be obtained by multiplying the matrix A by minus 1. Then we have discussed what is the identity element of addition of two matrices. So what we said, the identity element of addition of matrices is the zero matrix, and zero matrix means a matrix in which all the elements are zero, and we said the order of zero matrix is flexible. It means, okay, it can be taken according to our requirement or according to the given matrices. Okay, and thereafter we have discussed what is the additive inverse of matrices. What we said, for a matrix A, the additive inverse is the negative matrix minus A, because A plus minus A is equal to minus A plus A, that is equal to 0 matrix. Okay, now just we make a bit more discussion about the multiplication of a matrix by a scalar. Okay, so we said, okay, A is a matrix 1, 2, 3, minus 1, 4, 6, 0, 1, 2. Okay, and this matrix, suppose we want to multiply by 3, that is we need 3A. But we said 3A is again a matrix obtained by multiplying each and every element of the matrix A by 3, that is 3 into 1, 3, 6, 9, minus 3, 12, 18, 0, 3, 6. Okay, now just forget about this. We have this matrix 3, 6, 9, minus 3, 12, 18, 0, 3, 6. Okay, the meaning is a matrix is given. So we have discussed how to multiply a matrix by a constant. Now we think vice versa. We think vice versa means, okay, when a matrix is given, how to take a constant common factor from a matrix. So what do you have to make it out? For taking a constant common from a matrix, it is necessary that that particular constant is common for each and every element of the matrix. So if you observe this matrix, we can see that the constant 3 is common for each and every element. So since it is common for all the elements of the matrix, it can be taken common to the entire matrix. Means it can be taken outside. So it will come as 3, then 1, 2, 3, minus 1, 4, 6, 0, 1, 2. Okay. So, what we discuss? How to take a non-zero constant out of a matrix or common from a matrix. What is the condition? It must be common to each and every element of the matrix. And remember it very categorically, because later on we discuss about determinants. And in determinants also we come to how to multiply a determinant by a constant, and thereafter how to take a non-zero constant common from a determinant. Okay, and there the process is entirely, just remember, this much you remember now, determinant also has rows and columns. Okay, and when you come to matrix, that constant is common to each and every element. Means what? If there are 3 rows, the constant is common to all the 3 rows. Since there are 3 columns, the constant 3 is common to all the 3 columns, then only it can be taken outside. But when you come to determinant, you will see that for taking that constant common, it is enough that the constant is common to any one row, not necessary for all the 3 rows. Clear? Okay. So we have discussed how to take a constant common from a matrix. Okay. Now we come to one of the most important sections of this chapter. It is merely the operation, but most of the discussion of matrices in our syllabus is based on which one? The important operation, multiplication. So we come to multiplication of 2 matrices. Okay, multiplication of 2 matrices. Okay, actually we are all introducing the operations, because in addition also we said not possible to add any 2 matrices. For adding 2 matrices, it is necessary that the 2 matrices must be of the same order. So it is the very definition, or it is the very fundamental way of introducing the operation addition of 2 matrices. That is introduced, defines. So as I always say, there is no need of any confusion why it is so, because we are only introducing a new concept. Okay, we introduce by ensuring that the newly introduced concept or the method is not violating any existing theory of mathematics. That is only condition required. Okay, so when they come to multiplication of matrices, so multiplication of 2 matrices in the same manner, okay, we discuss, okay, how to multiply the 2 matrices A and B. Okay, so as we said in addition, in the case of multiplication also, okay, 2 matrices are possible to multiply provided the 2 matrices satisfy a certain condition. Okay, and again remember, here when we come to the multiplication of A and B, so we think of which one? The product AB, the addition also we will say that, okay, or we think of the product BA. Okay, so when we come to real numbers, okay, we know that if A and B are 2 real numbers, A into B is AB, B into A is BA, this is nothing but AB, because multiplication of real numbers is commutative. 3 into 2 6, 2 into 3 6. Okay, now we see what happens in matrices. So anyhow, what we said, when we come to A and B, so we come to the product AB, that is A into B, or BA, that is B into A. So anyhow, first of all, we concentrate on the product AB. So in the product AB, it is very clear the first matrix is A and the second matrix is B. Because here, which matrix comes first and which is the second matrix, that order is very relevant or very important. Okay, so remember, the product AB is possible only when the number of columns of A is equal to the number of rows of B. So what we say? The product AB is possible only when the number of columns of A is equal to the number of rows of B. Or in short, we say two matrices are conformable for multiplication only when the number of columns of the first matrix is equal to the number of rows of the second matrix. Clear? Okay. Now we discuss how to multiply two matrices with the help of an example. Okay, we consider A equal to matrix 2, 1, 4, 5. Okay, B is equal to matrix 1, 2, minus 1, 3, 4, 5. Okay, A is a matrix of order 2 by 2, otherwise A is a square matrix of order 2, and B is a matrix of order 2 by 3. Okay, here number of columns of A. We said number of columns of the first matrix, that is 2, and this 2 is nothing but number of rows of B. Okay, so number of columns of the first matrix is equal to number of rows of the second matrix. So the condition for the multiplication of A and B, or the condition for existence of the product AB, is satisfied. So we can multiply A and B, or we can obtain the product AB according to the condition we imposed. Now we see how to obtain the product. Okay, so here, see, what was the condition? Number of columns of A, that is this 2, must equal to number of rows of B. The common thing, just think, eliminated. Okay, now the relevance is to the number of rows. There are 2 rows of the first matrix and the 3 columns of the second matrix. The meaning is, once the imposed condition is satisfied, thereafter the relevance comes to the rows of the first matrix and columns of the second matrix. So we introduce the multiplication of two matrices as row by column multiplication. What is the meaning of row by column multiplication? Take the rows of the first matrix and columns of the second matrix and multiplying them. Multiplying them means multiplying the corresponding elements. Okay, so we say, we apply which one? Row by column multiplication, and we make it very clear with the help of this example. So what do you have to do? Take the rows of the first matrix and the columns of the second matrix. So we take the first row of the first matrix and first column of the second matrix, multiplying the corresponding element. See, how many elements in the first row of the first matrix? 2. how many elements in the first column of the second matrix? 2. Then what we do? Multiplying the corresponding elements. Okay, 2 into 1, 2, 1 into 3, 3. Corresponding elements are multiplied. Now these two products are to be added. So what do? Multiplying the corresponding elements of the first row and first column and adding the product. Okay, then actually now what we are doing is we are writing the product AB. The product AB is again a matrix, so it has rows and columns. So we are writing the rows and columns of the product AB. So first of all, we write the first row of the product AB, means the elements of the first row. And first row, first element, you are in 2 plus 3, 5. Then again we come to the first row of A and go to the second column of B, multiplying the corresponding elements. 2 into 2, 4. 1 into 4, 4. Okay. Then first row, third column, 2 into minus 1, minus 2, 1 into 5, 5. Same manner. Okay. So this way we write the first row of the product AB. Okay. What you have done? First row, first column, multiply the corresponding elements and adding. First row, second column, multiplying the corresponding elements and adding. First row, third column, multiplying the corresponding elements and adding. This way we have written the 3 elements of the first row of the product AB. Now for writing the second row, we come to the, again we are applying which one? Row by column multiplication. So we come to the second row of A, multiplying the first column, second row into second column, second row into third column. So 4 into 1, 4, 5 into 3, 15, 4 into 2, 8, 5 into 4, 20, 4 into minus 1, minus 4, 5 into 5, 25. Okay, then so we multiply the second row by the first column, second row by the second column, and second row by the third column. Okay, then simplifying it, 2 plus 3, 5, minus 4 plus 4, 0, minus 2 plus 5, 3, 19, 28, minus 4 plus 25, that is 21. Okay, so matrix 5, 0, 3, 19, 28, 21 is the product of A and B, otherwise it is the product AB. Okay, and see the order is what? How many? There are 2 rows and 3 columns. This is what we said. The condition we imposed for multiplication of the 2 matrices is number of columns of the second matrix is equal to number of rows of the first matrix. Okay, that common, actually is not no such division, but for convenience of understanding we can say the number of columns of A. Okay, the number of columns of A, number of columns of A, number of rows of B. That common thing, suppose it is eliminated. What is remaining? 2, 3. The 2 are the number of rows of AB and the 3 are the number of columns. The meaning is order of AB will be 2 by 3. Okay, look, order is 2 by 3. So this way we come to which one? The multiplication of 2 matrices. So when we come to multiplication of 2 matrices, the first thing to remember is it is not possible to multiply any 2 matrices. And second thing is, even if it is possible to multiply 2 matrices in the product, which is the first matrix and which is the second matrix, that is very important. Okay, and see here in our example, Okay, order of A 2 by 3, sorry 2 by 2, order of B 2 by 3, number of columns of A equal to number of rows of B. So product AB is possible and AB is of order 2 by 3. Okay, now we come to BA. Okay, the order of B is 2 by 3 and the order of A is 2 by 2. Number of columns of B, that is 3. Number of rows of A 2. What does it mean? They are not equal. Okay, the meaning is what? Even the product does not exist. Which product? BA. We are looking the two products AB and BA, and we said in real numbers 3 into 2, 2 into 3. Means A and B are two real numbers. So A into B, B into A, both are equal to AB, both are equal to BA. Otherwise what? Product AB and BA are equal for real numbers. Otherwise multiplication of two real numbers is commutative. But when we come to matrices, we have seen that product AB, here it is possible, but product BA does not exist. The meaning is what? Even the existence of BA is not possible in some cases. So then there is no question of generally the product AB and BA becoming equal. So in general, we say AB is not equal to BA. What does it mean? Multiplication of matrices is not commutative. Okay? Multiplication of matrices is not commutative. Okay? So in general, for two matrices A and B, it is not necessary that product AB and BA are equal. Some cases it may be, but generally AB and BA are not equal. So multiplication of two matrices is not commutative. Okay, and here we just recall the concept of the condition for two matrices to be conformable for multiplication. What we said, A. Suppose A is a matrix of order M by P. B is a matrix of order P by N. Okay, so number of columns of A. Okay, number of columns of A, that is P, is equal to number of rows of B, P. What does it mean? Number of columns of the first matrix equal to number of rows of the second matrix. The meaning is what? The condition for existence of product AB is satisfied. So the meaning is what? Product AB is possible, can be obtained by applying the row by column multiplication. It means take the corresponding elements of the rows of A, the columns of B, multiplying them, finding out the sum and writing as the respective elements. We get a matrix, and that matrix is of order how much? What is left out here? M, and here N. The meaning is what? Product AB is of order M by N. Okay, so the condition, which one? Number of columns of A, number of rows of B. Simply remember, whichever the common number required for the satisfaction of the condition, that common number is eliminated. The remaining M and N. What does it mean? The product AB is a matrix of order M by N. Okay, so just and the main thing to remember here is, when we discuss the addition of two matrices, we said what? Condition, the two matrices must be of the same order, and how we did the addition? By adding the corresponding elements. But not to have a misunderstanding in multiplication. What? In matrix multiplication, we are not multiplying the corresponding elements of the two matrices. Clear? But we are doing the row by column multiplication in matrices. So it is entirely different from addition. We are not doing which one? The multiplication of corresponding elements. Instead of that, we are applying the row by column multiplication, where in the multiplication of two matrices. And in addition, what we know? The sum A plus B and the sum B plus A are equal. Okay, the meaning is addition of two matrices is commutative. Okay, but multiplication is not commutative. Okay, so it's enough for today's session. Okay, and the theory we can say almost completed. Okay.